Welcome back. I went ahead and moved those into position so you didn't have to deal with me struggling with that. So what you can see here is I have 4 C's. 1, 2, 3, 4 C's. Now my B's have changed direction. If we look up above here, you'll see that B originally was moving kind of up to the right. Now my B's are moving down to the left, so they've gone in negative. So -1, -2, -3. Same idea with the D's. They've changed direction. They were going down. Now, even though I have multiple vectors, I still have chosen to do the head to tail method. My final resultant, I have all of these vectors being applied to an object. My final resultant, again using a ruler, would be to connect this point all the way across to this point. So nice straight line. This is the actual path that my resultant would take with these vectors being applied to the object. Okay, so the parts of the actual resultant are called the component vectors. So it's the reverse process. And it finds the forces that are being applied. So what will happen is you'll be given an actual vector, and that'll be the resultant vector. And so they'll ask you, well, how did that happen? And you'll find just two parts. You'll find a horizontal part that would create that, and you'll find a vertical part that would create that. These two pieces here are the component vectors that created those. A position vector simply occurs when they give you a point. So they give you point P somewhere on a coordinate system, and then the position vector is the vector created from the original origin to the point P. So this is the position vector right here. So let's show some examples and what these mean. So what this one has happening, we're going to find its parts, its components. I'm going to go ahead and draw this because it's giving me an angle of 212 degrees. So I know I'm starting still in standard position. That's why we learned that first. So from here, I'm going to create an angle. 90, 180, so 212 is going to be somewhere in here. And by having a magnitude of 16, that's telling you that this direction here goes out 16 units. Now if I want to find its horizontal and vertical components, I'm going to create, remember last chapter we had a reference angle, so I'm going to create a triangle to the x-axis, and I'm going to work within this triangle right here. And I'm going to find the components. I'm going to find x and y, which we just did in the last chapter by finding the sides of the right triangle. So I need to find this angle, which remember is our reference angle, and in the third quadrant we would do 212 minus 180, we would end up with a 36-degree reference angle. Now if we think back to last chapter, if I wanted to find this would be my opposite side, this would be my adjacent side, and the 16 would be my hypotenuse. So if I want to do adjacent first, and I have hypotenuse, adjacent over hypotenuse is cosine. So I could set up the trig function, cosine of 36 degrees. I don't know why I said 36, it should be 32, I just realized, so let's correct that. Okay, cosine is adjacent over hypotenuse, so that would be x over the hypotenuse of 16. Again, we would multiply both sides by 16, since it's dividing on this side, and that's going to be what our x is. That same process happens every time. So what we learn is that to find the the x or the horizontal component, we always take the magnitude times cosine of the reference angle. And then if we think about it, the y is the opposite. Opposite in hypotenuse is sine. So we would do sine of 32 equals y over 16. we would do the same process of multiplying by 16. And so every time we end up trying to find the vertical one, it's the magnitude times sine of theta. Now, besides that, you will still have to put in if it's a negative or a positive. So in this instance, both x and y are negative. So when I go ahead and plug these into my calculator, I end up with 8.5 and 13.6. But since they're moving in a negative direction, I have to make sure that I'd say that my horizontal component is a negative 8.5 units. And my vertical component is a negative 13.6. So I have to make sure that my vectors have direction. So the negative gives me the direction. Okay? So each time we can just go straight to this instead of having to go through this process now every time. In the next one, they just tell us it's a V of 9.75 and an angle of 16. So what they've done this time, you can still put it on an x and a y coordinate if you would like. So you can still start here, just go up 16 degrees, draw your triangle. So this angle is 16. When they say V equals 9.75, again they're talking about the resultant vector being 9.75 units. We don't know what the units are. So we're just going to go for the horizontal component. 16 times cosine of 9.7, oops, I wrote those backwards. Let's fix those. Because it's magnitude, which is 9.75, times the cosine of 16 degrees. And for the vertical, we'll do 9.75 times sine of 16. We'll plug those on in. In this case, we're in the first quadrant, so both our horizontal and our vertical are positive. So our first one is approximately 2.69 units, and our other one is 9.37. They're both positive, so I have direction as well as magnitude. The third example is giving with a P. That's simply saying that kind of like when we talked about a position vector. So if I think about, I'm starting in standard position, 317 degrees, 90, 180, 270, so I'm over here in the fourth quadrant. I've gone 317 degrees, so I have to think about what my reference angle is. 360 minus 317, 3 gives me 20, so I'm up to 43. So this is 43 degrees, and my magnitude of my resultant is 24.6. So for my horizontal component, I'm going to do 24.6 times cosine of 43. For my vertical component, 24.6 times sine of 43. X is moving to the right, so it is positive. And so it's approximately a 17.99. And my vertical component is going down, so it's a negative 16.78. So we can also switch it up, and instead of giving us the resultant vector and asking us to find the parts, the components, we can go the other way and give you the components and you tell me the parts. So in this case, they say vector B's horizontal component is 10 and its vertical component is negative 24. So 10 would be going out 10 and down 24. So it's down here in the fourth quadrant. This is 10, this is negative 24. There's our theta. So if we think about what we did in last chapter, find the hypotenuse, we always just did the Pythagorean theorem. So we could do that again. 10 squared plus negative 24 squared would equal my hypotenuse squared. So 100 plus Mthpt-137-60 gives me 676. Square root that. So I end up with 26 for my hypotenuse. Now to find my reference angle, since I would use, now 26 ended up being a whole number, so I could use it, but you never know if it's going to be, so I would always use your adjacent and your opposite, which means you're using tangent. So tangent of theta would be my opposite over my adjacent. So that's negative 24 over 10. Whenever I'm looking for an angle, I do the inverse. So just like we had general rules for above when we were finding components, we can make general rules for finding these. So when I'm finding my resultant, or b in this case, it would just be the square root of my x component squared plus my y component squared. So that's Pythagorean theorem written down solving for c. And then I could do, to always find my theta, it would always be inverse tangent. And because I want the reference angle, I don't have to necessarily worry about the fact that it's down. So we're going to do the absolute value of my two components. Notice my y component goes on top of my x component. So these are our general rules we can always use. That's what we were doing over here. I always just had the negative in there that would tell me that it was going down, but when we're dealing with our directions, we don't necessarily do that. So my reference angle would be 67.4. Okay, let's do one example of a word problem. A ship heads into port at 12 kilometers per hour. The current is perpendicular to the ship at 5 kilometers per hour. What is the resultant vector of the ship? So I have one vector, and it doesn't matter which direction it's saying right now. We just know that this is 12 kilometers per hour. The other one is perpendicular to it at 5 kilometers per hour. So since it's perpendicular, I'm going to go ahead and do a head to tail. So here's my 12, here's my 5, and it wants to know what is the resultant velocity. So I'm not worried about direction right now when it's just talking about velocity. I'm just worried about magnitude. I can see that I've created a right triangle, so to find that I would do the Pythagorean theorem. 12 squared plus 5 squared equals my resultant squared. 144 plus 25, it's 169, which gives me a 13. So my resultant velocity is 13 kilometers per hour. So my river is actually helping me, or the current is actually helping me. It's speeding me up just a tad bit. Okay, so work on 8.1, learn about vectors, see how that goes for you. If you have any problems, definitely let me know, and we'll continue on later on. Have a good day.